All right. Well, hey, Niners. Thank you for watching Eric Meyer's incredible lecture series on the fundamentals of functional programming. He used Haskell, but also talked about other things, C#, F#. You guys asked a lot about F#. Well, lucky for us, Dr. Don Syme is in town and has agreed to do lectures for us. So without further ado, thank you, Don. Don is actually the creator of the language. Great to see you again.
Yes, it's great to be back here. And thank you for everything that Channel 9 has done for F# over the years. I remember the first video, I think, done with one of the shaky cameras.
Yeah, in Cambridge.
Actually, no, your colleague did one before that here, even way back
Absolutely.
in the archives.
What was
look back
his
in the
name?
archives.
Way in the archives.
Yeah.
He was actually somebody who created content that didn't work for the team.
Yeah,
He's working in the mobile team.
That's him.
I can't remember his name, but thank you, man.
Yeah.
Right on.
watching
So,
today.
hey, take us through this.
All right.
F# tutorial.
It's my absolute pleasure to be presenting here at Channel 9. So what we're going to be doing is running through 3 or 4 part lecture series on the basics of F# programming. We're going to start today with a little bit about what F# is about, why we're doing F# as a language here at Microsoft. And then I'm going to be taking a walk through some simple uses of functional data, generating functional data and working with functional data in F# programming. I'll also be running through 2 demo scripts that we use often in F# talks. They're good for disorienting yourself about some of what F# programming feels like in Visual Studio. Okay, so to start, I'd like to take a look at what is F# about, or why is Microsoft actually investing in a functional programming language anyway? And when I draw out these themes in lectures that I give, I like to draw out 3 particular themes that seem to that resonate in the decision-making process that led to the fact that F# was being productized, brought up to product quality as a programming language in Visual Studio. Let me just quit my Skype account here. Alrighty. So the first of those themes is to do with simplicity, and this is largely to do with simplicity in problem solving. As you write up solutions to programming problems in your programming language, there's a consistent recurring simplicity to doing problem solving and data manipulation and expression of algorithms when you're using a functional programming language. The next sort of theme is to do with economics, so that's to do with the economics of the .NET platform in particular, the economics of building programming languages. There's been a long history in programming languages for a desire to have a high quality functional programming language available, which will interoperate with a lot of libraries and so on. But it's always been quite difficult to construct the actual compiler, the runtime, and the libraries, and the tool chains, and everything else that is necessary in a modern software development environment. And when I arrived at Microsoft in 1998, 1999, and was here, I had the good fortune to arrive at the beginning of the .NET platform. And it was immediately apparent that this multi-language view of the .NET platform could just really change the game for the economics of doing language development. Now that doesn't mean you can just sort of make a language overnight in some way. You just make a language and suddenly all the tools light up overnight, and it's actually, F# has involved a lot of work over the years, a lot of work on the design side, a lot of work on the compiler implementation side, and a huge amount of work of putting out the language for use by working programmers and for use by people interested in functional programming, the overlap between functional programming and parallel programming, for example, or looking at people who just want to say are learning C# and want to move over to the functional programming space for a while to kind of work out what it's all about. So there's a huge amount of work in just putting F# out there as a research project over the years, release after release, getting lots and lots of fantastic feedback, maybe from many of the people who are watching this video. So thank you for everything you've done for F# in the feedback you've been sending, and in telling us what works and what doesn't. So as we've iterated that over the years in a research project, it's still been a research project of 1, 2, 3 people at Microsoft Research in Cambridge working hard on this language and its compiler and the F# Interactive and some of the other tools that are special to F#. Then, of course, we moved in the last 2 years to the mode of making it a first-class language in Visual Studio and bringing it up to that product quality level where the language, the language is, not going to change. We get binary compatibility over the various releases going forward. We're going to the library's there. It's stable, and they can rely on that. Things are absolutely stable in the language design, the language implementation space. That's been an effort that's involved about 10 or 12 people here, a fantastic team at the Visual Studio Languages team here at Microsoft. In the big picture, that's a relatively small investment for making a new language, and that's because of everything that .NET gives us. We get the garbage collector, the just-in-time compilers, the tools, the profilers, all the libraries, this wonderful ecosystem of .NET components, many of them contributed, of course, by the broader .NET community, and also on the other platform. When we talk about .NET, we often think about like the .NET desktop, common language runtime implementation, but of course we're also thinking about Mono and Silverlight and Moonlight and all the other aspects of .NET development more broadly, all of which will tie in with F#. Okay, so in many ways, F# has been about bringing functional programming to .NET as something, sort of a mode of expression in programming, which making that mode of expression viable in the .NET ecosystem. Of course, there's been other great contributions in making functional programming viable in C#, in the extensions to C#, but we're also bringing sort of a functional first language into the .NET programming environment. And from the functional programming perspective, for those people who've been engaged in working with functional programming languages, it's also about bringing .NET or a modern, rich ecosystem of software into the functional programming experience. So they can perhaps learn their functional programming in Haskell, learn it in OCaml, learn it in Scheme, and then those skills that they've learned for problem solving and software design can be you can take those and transfer them and use them in a production context, in a .NET context, in this case. So the last theme that consistently resonates is to do with parallelism. This is going to be the topics we're going to explore in parts 3 and 4 of the tutorial. And the overlap between functional programming and parallelism is an interesting one, and I'll draw out those themes a bit later on. I'm not going to be making the case that you can immediately, implicitly parallelize your functional code through some kind of magic, that there's not some button on the F# compiler which says like go parallel or something. But so the argument is more subtle and more overlapping than that. But there are functional programming makes many contributions to parallel programming in your ability to express task parallelism cleanly, for example, and compositionally. Your ability to manage resources and exceptions as you express, say, an asynchronous I/O parallel operation. And your ability to have declarative sub-languages like LINQ is a classic example of functional programming, of embedded declarative language. And you can take those languages and give them to engines like the database engine. You have them embedded in your program and give them to a database engine, and they can parallelize them. But a big part of that is the fact that you're building on functional programming modes of expression in your source language. The functional programming modes of expression, meaning ones that are free of the use of imperative state all the way through, and are declarative expressions of the query you're trying to execute. Okay, so let's take a look at some of those themes. Let's bring out the theme of simplicity a little bit more. What does it actually look like in code? Here's so I was working over the years. I've had the pleasure to work with Anders Hallsberg, and we sat down in the pub in Cambridge a couple of years back and I had to ask him, I was sort of new to the game of of giving talks about F# at major venues, and I was saying, look, how do I explain this F# stuff to people? And he said, just get the code samples. Take the code samples of C#, take the F#, put them side by side, people will get the idea, okay? This isn't actually, it's not the world's greatest code sample. It's just like taking a number, defining a number A, which is going to be some sort of public property that can be accessed, and also then printing that out. And it's just like a more or less literal C# translation of that program. When you compile both of these, you get the same .NET metadata or DLL, for example, out the end, or an exe in this case, out the end. Part of the point here is, of course, that that there's two approaches to programming going on here. We've got scripting on the one hand. On the F# side, it's obviously you've got a sequence of commands: open system, let a equal 2, print that out. And on the right, we've got a much more structured, object-oriented approach to expressing information. Now, there's absolutely a role for both of these in software development. But it's sort of, what do you start with as you come to write your code? And in F#, as you come to explore a problem space, F#'s very much about transitioning from a exploration of a problem space using scripting, but staying statically typed as you explore a problem space, through to developing more realistic software components using object-oriented techniques and packaging them as components, and then transitioning that through to deployment, because to the .NET component, you'll be able to deploy it in the usual .NET way as your DLL or the like. So it's sort of a exploration first language, a sort of scripting first, functional programming first language. So the starting point is substantially different from the C# experience. Some people might say there's just a lot of noise over here on the right. That noise, that may be a bit unfair, because these names that you have in console application, these long names, can serve a crucial role in making software maintainable. But at the initial outset, you might say, many people might say there is quite a lot of noise here. But I just want to say it's not actually opposed to the structured object-oriented software. It's just we tend to place it a little bit later in the software development cycle in the F# context. Okay, so let's take a look at some functional programming here. We've just got a simple functional programming F# expression of the command pattern out of one of the design patterns from the Gang of 4 design patterns from the 1990s. Okay, so the F# expression here is pretty good. We have a new type. It's like defining a new class, effectively, which is going to be a type of commands here. And then each command is going to be a function which takes a rover and does something to it. It returns, okay, it's an imperative command which returns unit. That means it's modifying doing an action on the rover in some way. Unit is the equivalent of void in C# programming. And we have a break command and a turn left command. It's a straight F# expression of one of these standard design patterns. And now if we take the strict object-oriented view of this kind of design pattern, okay, we're not saying the C# view, it is C# syntax, but this is doing it in the object-oriented mode of thinking, and the way of thinking about this is a contrasting functional programming, modeling of information, versus the object-oriented programming, modeling of information. Okay, then one of the key things you'll notice is that F# is much less oriented towards this hierarchical thinking. Okay, there's a typical thing in the object-oriented mode of expression that when you sit down and analyze a problem, you'll start making hierarchies straight away. And the hierarchical modeling does play a role in F#, but a much reduced role. Already in .NET, it's substantially reduced from the Java experience of software design. And in a sense, F# is taking that a bit further. You can still do it. It's absolutely crucial to some later aspects of software design and development. But in this case, you won't, in the F# way of thinking, be led towards a class hierarchy for solving this particular design pattern. So the design pattern in the object-oriented world has your class of commands, execute, and subclasses that with a Mars rover command, which has a rover field, which has sort of get properties and so on. This sort of captures the current rover, and then you subclass those, and it goes off the end deliberately. Here we have a break command, and it goes somewhere down to the bottom of a Mars rover command, which actually does, I think under here is the execute is where the first accelerate actually happens in your modeling your families of commands. So let's just take some other samples of a kind of programming. It's just one of the basics of functional programming is taking these easy and fluent manipulations of data. So we have data meaning like we have tuples, we have lists, and we have functions which work with these data structures. So something which say swaps the elements of a tuple or takes the rotations of a tuple, x, y, z, and so on, and builds a list of those. and a function which takes a function f and applies it to all the elements of a tuple. And of course, C# is a great language. It has tuples in .NET 4.0, but when you look at how this gets, these sort of manipulations might appear from a C# programming perspective, then things are a bit long, and in particular, you'll notice in the F# world, you get what's called automatic generalization. You get generics for free. The F# works out that this swap function is actually a generic function in this beautiful aspect of programming language design called generalization from the sort of Hindley-Milner type inference, where you work out that this is actually automatically work out that it's a generic function, and that it will take any pairs, a pair of t and u, and return you a pair of a u and a t. Okay, so this is what we have in the C# code, and then similarly for working out the rotations, well, okay, things kind of get a bit long. Here we have a read-only collection being returned, and all the tuples have the same type here, and then you have to create that, and so on. It's all a bit long for manipulating these basic data structures. Similarly, we've just gone off the bottom here, but we've have a reduce function here, and it goes on. This is taking a function and applying it to each of the elements, and then adding up the elements here. You can write that again in C#, but it's not what you'd naturally write. In part, and because this stuff tends to be a bit unnatural to write in say the C# or the Java kind of world, the actual pleasure of programming with this kind of data structure as part of your problem-solving experience tends to be absent in that kind of world. Okay, so you can do it, but it's just a little bit more painful than I would like. So if we look at, say, another typical programming problem, in this case is modeling an abstract syntax tree here. We've got some model of propositional logic, the syntax, the terms of propositional logic. We have ands and ors and nands and XORs and nots. You might use this kind of modeling language within, say, a circuit synthesis pipeline. You get some data in which describes the circuit that has to be implemented, and you put it into this form, and then you do some manipulations on this, and you generate a circuit out the other end. Then, again, in the object-oriented way of thinking, you'll be led towards a hierarchical modeling approach to expressing this kind of structure. And that's fine. There are cases where this is all very good. It works well. But the F# aim is to get you thinking less about this kind of modeling and more with working on the manipulations of that you're doing with the data. So it's focusing on what you can do with on your domain. Your domain here might be being smart algorithms for generating circuits, for example, and a little bit less on the software development side of things, on writing the code, as it were, writing the code here, which has, say, a unary operator extending expressions and binary operator extending expressions, and then it actually goes really down a long way before we get to modeling these different elements in this abstract syntax tree. Okay, just to give another example, you might be modeling a little language of events in the history of a stock price, for example, a typical bit of financial data modeling. An event might be a price or a split or a dividend, and these, as you go through, you can replay the history of these, and you can make a graph, for instance, that displays these nicely. And in here you can see that at F# you can annotate floating point numbers with quantities like money or kilograms or meters or something. That's called units of measure in F#, which gives you a little type system for floating point numbers. And I'll be covering that in one of the later tutorials that we do. Okay, and over here again, it's the same sort of hierarchical modeling: events, prices, split events, and so on. And again, it's that painfulness of this longer mode of expression for saying something simple when you actually want to move on to do your work of manipulating this data more than modeling the data itself. Okay, this simplicity and pleasure carries over to parallel and asynchronous programming. And I'm not going to put up the C# code examples for this because it would depend very much on what set of libraries you're using, which asynchronous and parallel programming libraries you're using. F# has a very nicely integrated feature called the async programming features, where you're sort of composing up computations, which you can then press play on, and then some of those computations get executed in parallel. So here we have a parallel fetch of a set of web pages. So we're going to make 3 web requests, okay, simultaneously, and we're going to wait till all those results come back, and it does a fork join, and then gets those collected results, and then continues on. So this get page actually isn't defined in the library. I've actually cheated a little bit here. It's a 5-line definition. We'll be looking at the definition of the what we call the HTTP async, HTTP get on a page. We'll be looking at that a bit later on in the tutorials. Okay, you could also use this for parallelizing CPU computations, and it's quite a reasonable way to do this. You could also use the task parallel library, parallel.4 and so on for expressing this on .NET 4.0. You can do this. One thing that's quite nice is this works on .NET 2.0, works on all the platforms, the Mono and everywhere else, all the platforms that support where F# will execute. And so here we're creating 201 tasks, and there's some sort of compute task which is just going to do some CPU computation. And we take the parallel composition of these. I just got to say, when you do this coding, you do have to put what we call piping this parallel composition through run synchronously to actually run the composition, and then they'll run in parallel, and we'll wait for the overall result, and then we'll get the result. Okay. And then you'll get an array containing all the results from the elements of the computation. Okay. Okay, so let's just drawing out this theme of simplicity. So let's take a look back on influences on F#. It's hard to do justice to the full history of programming languages. When you look at some of the influences, like it goes way back to the 1960s, Peter Landon's famous paper on the next 700 programming languages, I think, where he talks about like white space syntax for programming languages, which then made it into like Python and into Miranda, and I think into Miranda, or into Haskell in any case, which also influenced F# heavily. But when you look at the core language constructs, and also the way of thinking about functional first programming, while still embracing object-oriented programming and imperative programming in some parts of the programming problem, then we're getting back, the core language and the core sort of methodology in many ways is so strongly influenced by OCaml. So, you know, there was always this aim to get some of the experience of using the OCaml core language, which is then in turn related to the earlier versions of what were called the ML family of languages in the context of, say, Edinburgh ML and Standard ML. And to get some of the experience of programming with those languages in the context of .NET development. There were some great research projects which also strongly affected F#. There's a project called MLJ for running ML on the Java platform, and also one called SML.NET, which was done at our research lab in Microsoft Research in Cambridge. But at the same time, there's a decision point here when you come with you sort of come with the existing approach to programming, and you come to the .NET platform. Do you try and isolate yourself, so you're just embracing this original kind of programming, but not actually embracing sort of what you learn from the .NET platform? And I think by coming to the .NET platform, I personally learned a huge respect for the C# and .NET view of object-oriented programming. You partly learn that by needing to interoperate with C# and .NET. But then over time, we've really refined the object model that you have within F# to get a very nice mode of object-oriented programming, .NET style, C# in a sense style, object-oriented programming in the context of this F# language, with these lovely type-inferred objects, for example, coming from C#. Since then, we've had some really important influences as well. There's this influences from Haskell, syntactic influences from Haskell. There's influences in in the F# computation expressions feature, which we use for queries, and influences from C# LINQ have come along, influences from Python. In some ways, I do like to think of F# as a strongly typed Python for .NET. Syntactically, it's not exactly like Python. There are definitely syntactic differences that can make a difference in practice, and I'm sure the Python programmers might say that's not how I should be thinking of it. But in terms of trying to get close to that sort of succinct mode of expression that you get with Python, but to keep the static typing, to make sure we keep the performance profile and we keep the development experience with the red squigglies when you've made a basic mistake, and the hover over identifiers to get information. And this will always be a strong theme in F#, is to keep the sweetness of that dynamic language experience, at least as much as we can, but keep it in the statically typed kind of view of the world. And it's not. And Anders Hallsberg captures this very nicely. Static typing is not just about sort of hitting yourself with a stick over the back to kind of make yourself to feel the pain if you do something wrong, or feel the pain of putting lots of type annotations on your code, which you don't really have to do in F# anyway. But static typing is really very much about the development experience as well, about making sure, like, static typing means there is a sensible analysis built into the language that can be performed over your code, which gives you lots of information about your program. And because we've got static typing, that means that you can get all this, the compiler can help you tell you a lot more about your code. Okay, it knows what the types of everything is, and it can feed that information back to you. There's always a fundamental part of the C# design experience as well, and that's fundamental to F# as well. Okay, so this heritage between functional first but embracing an object model goes through in the methodology of using F#. So here's a quote from Julien Laugel at Eurostox. He's a chief software architect there. He uses F# quite a lot to prototype his algorithms, and then he'll hand those off either to be used in larger components at the company. The key thing I like about this quote is obviously it's a nice quote about F# about working with the language, but the fact that he talks about has pure functional code. He shifts slightly towards object-oriented and imperative programming later on in the software cycle, but that means it corresponds to this functional first thing. He starts with a pure idea and he's finishing his project with realistic code. So that captures this sort of methodology of using F#. Okay, so to finish up on this first part of this tutorial, what we're going to do is just look at some really simple F# applications. Okay, so it's going to be no surprise what the first one is here. This is an F# program here which prints "Hello World." Okay, using the printf library that comes with F#, we could just as well use system.console.writeline Hello World, and so you could use the .NET libraries directly. There's a small I/O library called the printf, or formatting library called printf, which is a strongly typed printing, which you can use from F#. Okay, and you can compile this program just to say we can use it in F# Interactive. We can highlight it and we can send it across in Visual Studio, or we can also just compile it here and we get a test.exe and we run it and we get Hello World. Okay, let's take a look at the next application just to show using the .NET libraries and a few idioms here. We make an open System Windows form. We say we create ourselves a form and we set the visible property to be true. And every time the form gets clicked, we add an event handler here, fun, printf, and click. And then we call application.run on the form. And you can compile this up, or you could run these lines here, these first 3 lines. You don't need to run the last one in F# Interactive. And you can play with Windows Forms and create them. And the same code will work across many different platforms. For instance, you could run the same code on Mono on Linux, and everything will work well. Let's take a look at our third application. And this is a bit just where this is just a typical example of computing something, this famous Fibonacci function. So the fib function taking some input x, and if x is less than 2, we'll return 1. Otherwise, we'll take the fib of these two numbers and add them together. And this will be a recursive function, so you mark that up here with being recursive. Now, what we can do now is we can create an array of numbers here from 1 to 40 here. And we can do, so that's creating an array, and we're going to take a function, this fib function, and map it across that array to get ourselves a new array. And then we can print those results out. With %A pattern is a marker in the formatting. Again, you could print this using the standard .NET library techniques. In this case, the %A is a very helpful little function because you'll format and see all the elements of the array. So let's just take a look at this code. So I'm going to just come here and take it out and switch over to Visual Studio here. We'll paste it in. And we'll take our first line, first program that we had, hello world. Okay, and we highlight this, and we'll just do a little reset on my session here. Okay. So here we've got F# Interactive in Visual Studio here, and we've got edit, so a view, other windows, F# Interactive brings this window up. And now we can take these little applications that we had, and we can highlight the code and we can execute them in F# Interactive below, or as I said, you could just compile a program containing this and you'd have your first F# program. So let's take a look at the Fibonacci function. We can highlight this and down below, look at it down below. Now when we highlight in Visual Studio, you'll see it knows the type of the Fibonacci function, taking integers to integers. And you can see that that's the type that's been reported, that Fibonacci is a function taking integers to integers. So now we can take our array.map of fib over the numbers from 1 to 40. And it takes a little while because there's a little bit of computation to be done here. And we can see the array of numbers being printed out, which is the result of our operation down below. And we can display those results again using this printf function here. Okay, so 3 very simple little F# programs. Okay, just to say, to give an example of making parallelism simple in F#, for example, we could modify that third F# application to have an array.parallel.map instead of an array.map, and that'll do a parallel map over these arrays. Over this array. You get the same result, but it'll be executed in parallel on a multi-core machine. Just looking at a couple of other fundamentals to help you orient yourself in the F# syntax as you start to work with the language. We have this let construct here, which is just used an awful lot in the language. You'll see we use let here to make some static data here, just to say this gets evaluated straight away. We create ourselves a tuple and we store it. It's in this associated with this name called data. And here's where we have a function here where we take 3 inputs and then we sum them up. We have an inner function here, so we use let here to have some local values and let here to bind a local function. Okay, so let is just this consistent way of declaring and working with data and transforming data and working with objects in both in static data functions and inner positions. Okay. All of this is type inferred, so when you hover over the code, you get the safety of C# with the succinctness of F# as the scripting language. Okay. Just to say, you've probably already noticed this, you may know this about F# already, but it's important to note that white space matters in the language, and when you go on to do your first F# code, make sure you understand this, that if you don't indent these lets correctly, there's what's called an offside line. It comes from soccer, from football, soccer, and you got to line these ones up here, and that's how the syntax ends up kind of light, and you don't need lots of extra tokens, and how it disambiguates the meaning of your program. And there's a great benefit to that is F# code looks very regular because everyone is lining it up like this. Just a couple of last things is comments. You can see this. You can see the mixed heritage of the language here. We've got C# comments here and OCaml comments here. That's got to do with the heritage of the language. And okay, just to mention, just documentation at the top of your code, and if we look here, you can also use the full XML docs at the top of your code as well, just the standard XML docs that we all know and love from C#. Okay. Just to mention, you'll see a lot of function values in F# programming. We have anonymous functions here, defining functions, using functions as first-class values. If you like, just think of these as delegates. The fact that you can automatically name any function f and use it as a delegate or as a function value, have a pair of functions or a function type down below. Functions just get used for modeling a lot of things, for modeling predicates or for sending a message or for doing a thread start. This unit here, as I said, represents the notion of void in F#, or for hashing or for comparing values or comparing them for equality. Okay, so just looking at some basic arithmetic, you just all the usual things you expect here, the booleans. But you don't use the bang for not, you use just not down here, but otherwise everything is as you'll expect. And we have basic types and basic literals. So let's take a look at some of these. So it's the usual thing you'll see from C# here. You'll have characters here, we'll have the ticks around them. And one change that we have here is that when you use the more exotic types like int32 and the like, you do put a little annotation to indicate that is a particular literal in a particular type, U for the unsigned ones, for example. Okay. And just to say, you have big integers in the language down the bottom. We just put an I at the end of your number and you've got your big integer. You'll see a lot of pipelining in F# programming, where you take an object and you pipe it into some function. Okay, so the pipeline operator. So this just means taking the function and applying it to the object. It's just putting the application the other way around. The advantage here is that you can take some value and you can put it through the pipelines of various functions and you get the overall result out at the end. Okay, successive stages in a pipeline. So we'll see that by when we take the files here. So say we get a list of the files using the system.io libraries, this list of the files under C:/. We want to work out the total size of those files. We take the files and we map a function. So you take this input data, is a list of files, and you transform that to be a file info for each file. And then you map it again and you get the length of each file. And then we can sum up those lengths, for example. So just straightforward data processing, taking it in, working through the process of transforming the data and then doing an analysis of it at the end. So summing up the file sizes. Okay, so we're going to leave it there for the first part of the tutorial. I'll just skip ahead to the wind-up slides here. Okay, just to mention, if you want to go ahead and read some books about F#, there's these 4 books, a great set of books you can use: Foundations of F#, Expert F#, F# for Scientists, and Real-World Functional Programming. There's several other F# books out. We'll be talking about those later in the next tutorial. There's one called Programming F#, the O'Reilly book, which is by Chris Smith on the F# theme, which I also strongly recommend. Okay, so we'll leave it there, and thanks very much.